I was using my chat socket.javascript, so I was using a WebSocket connection instead of the HTTP post connections. So I was writing the code that I was changing, wasn't being called at all. It was running that server, but I had that server set up a little differently to use WebSockets. So let's see this the right way, which my WebSockets I was using with the same example. So this WebSockets were insecure intentionally, but I didn't realize it. I have another method, which I shouldn't have duplicate code. Anyway, let's run this thing and see the activity the way, or the demo the way it is supposed to be. So I'm running this server. I have it open in 2 different tabs. I can chat between those tabs. And there'll be a little bit of delay on the chat, but I can chat between them. And on the other tab. But since we're not escaping HTML, and let's get into inspect element here. Since we're not escaping HTML, we can do things like horizontal rules, and any, which is just a proof of concept that we can have any HTML that we want here. So H1, I'm not going to try to do the JavaScript again in case it doesn't work. But we can submit HTML, and that text is in the other tab. So any HTML, which can include JavaScript, is going to show up on all users' machines, because we're taking it in our server and then sending it to everybody and then rendering it as HTML. This is something we want to avoid. So the way to avoid this, simplest way, is to escape these 3 characters. So now anytime we get a message from the chat, we're going to run this code, which is going to replace these 3 characters with their escaped values, their HTML escaped values, and then they're not going to render as HTML. So let's restart this server. Go back to our tabs. Hello. Still works. And then we're going to try to attack again. We're going to say H1 attack. And now that text just renders as straight up text. It's not rendered as HTML because we escaped those characters. So if we look at this element, that's not actually just those characters. It's going to render it as that in the console. But it's actually the escaped characters. It's the ampersand. I think I can see it in the network tab. So it's actually the escaped characters that are being sent from the server. So this is the actual string that we're getting from the server. This is the actual information for the chat history. And then when we render it to the screen, when the browser renders it to the screen, it says, oh, ampersand GT semicolon. I'm going to replace that with a greater than symbol. The ampersand amp semicolon, I'm going to replace that with an ampersand. So these are escaped characters like we see in programming when you usually have like a slash, and then like if you want a double quote in a string, slash double quote. We're doing the same thing here where the extra characters are not showing up, not being rendered to the user, but it's a way for us to say, hey, I want the literal character less than, greater than, ampersand. Do not interpret these characters as HTML. And that's how we can get some sanitation in our chat. This is what we call sanitizing your HTML or escaping your HTML. And this prevents HTML injection attacks, which prevents JavaScript injection attacks. Pretty simple to do, pretty straightforward. Escape those 3 characters. Extremely effective against this attack. If you're vulnerable to this attack, anybody who has any basic amount of HTML can attack your site with my favorite attack is just this. Just send that to the chat. It's not going to break anything now, but that would be the start of a block comment in HTML. Now everything after that in chat or before it chronologically is just gone. It's just not rendering to the page. It's still there, the content's still there, but nobody can see it unless they're opening up the console and doing that kind of stuff. Super simple attack, just 4 characters, and a lot of the site is just gone. Any footers are going to be gone. All that stuff's gone. Super simple. That's my favorite attack because it's so straightforward. Anybody who knows about block comments in HTML can attack your site pretty easily. But once you escape those 3 characters, how are you going to attack it? How are you going to inject any HTML without those 3 characters? Not going to happen. I mean, possible with some really weird, maybe there's some really advanced stuff you could do to get around the escaping, but unlikely. It's going to take a very, very sophisticated attack to be able to get around this. So that's what we want. So when we're testing and when you're testing for HTML injection, make sure you're using those 3 characters, submit any HTML, a header element like I did there, and make sure your site renders it as just straight up text and doesn't render it as HTML. All right, any questions on that? And a reminder, I have the Discord lecture channel open here. Any questions about that or anything before we get into some new content? I say new, but I foreshadow this so much that you should all know what's coming. We're just going to talk about how to do it. Let's talk about buffers. So now we have file uploads. We have requests coming at in this format. And yes, there is, I made sure it's in a slide this time, so anybody studying just off the slides can get this information. There is a /r/n right at the end of each boundary. So right here, there's a /r/n. So if you append that to the beginning of your, it's not exactly the right way, but if you append it to the beginning of your boundary, you can, I don't even want to say that because depending on how you handle this, that's the way I like to do it, but anyway, there are /r/n's at the end of each part. So make sure you're taking that into account. If you have the bytes of the file and that /r/n appended to the end, it can mess up the decoding of JPEG images, and you won't be able to render those images. Just keep in mind that there are new line characters there at the end of each part. So before each boundary, with the exception of this one, before the boundary is just the /r/n/r/n. That's the end of the headers. So however you want to parse all that, make sure you're handling those new lines in your parsing. And to get this information, you're doing one of these 2 things. And now the homework one's in, and I can see the languages. I can confirm that the vast majority of you are using either Python or JavaScript. With a handful, I think about 5 students are using other things, Scala and Go in Java. There's a sprinkling of those 3 languages. Most of you are using Python and JavaScript, so I can focus my examples on those 2 for the most part. And I'll have some Scala examples just because I have a lot of Scala code and work in Scala a lot with 116. But you're probably doing one of these 2 things. The majority of the class is doing one of these 2 things. To read bytes from the socket, with the first one being JavaScript, the second one being Python. So let's talk about this, what this is actually doing, and how we're going to handle very large file uploads. So we're talking about Objective 4 this whole lecture. And for some of you, depending on which browser you're using to test, Objective 3 as well. Sometimes with even very small file uploads, I believe Chrome does this kind of notoriously. You'll only get the headers without the file contents. And you have to do some of this even for Objective 3, depending on your testing environment and how you're testing. So a TCP connection, so far we've been treating it as like a one and done kind of thing. The user connects, sends some bytes of information, we read those bytes, we process it as an HTTP request, we serve up the HTTP response, and we're done with it. One read from the socket and we're done. But TCP is actually a streaming protocol. So that connection stays open. We have 2 ends of the socket open, and then we can send 2-way information back and forth over this TCP socket until one side closes the connection. Now for HTTP, we treat this as a, usually, or I shouldn't say usually, but for HTTP, we treat this as a one-way request. So the client can send us information, and then we'll respond to the request. So we do send information over the socket, but we don't actually send information unprompted. Just a little foreshadowing on this, we will when it comes to WebSockets. If you want a really quick definition of what WebSockets are, it's taking the TCP connection for an HTTP request and just using that for two-way communication. That's the very, very brief definition of how WebSockets work. So for our purposes now, we're receiving a request and then sending a response. But this is a stream. TCP, the protocol, can do a lot more than this. It is just a two-way tunnel, a two-way communication with streams of data. So it's meant to be a persistent connection and just keep sending information, sending information, sending information. So we can't just say read from the socket once and get all of the information that we're going to read. Instead, we're going to read a certain amount of data from the stream. We're going to read a bit of information at once and then handle those bytes. So if we have an image here that's very large, how are our TCP socket connections going to handle that, and how are we going to make sure we have all of that data? That's what we want to answer today. And what if this is even in megabytes, gigabytes? What if somebody's uploading a gigabyte file to our server? How are we going to handle that? We won't test with gigabyte files, but we'll test in the megabytes for sure. So what if we have a file like this big? A megabyte, I think I did this, is 1.8 megabytes. How are we going to read that? So in Python, we see this hard-coded constant here. This is the size of the buffer, and this is of the TCP socket buffer. And this means that you're going to read at most 1K bytes from the socket when you call this receive method. So we're going to say, hey, TCP socket, you got anything for me to read? If you do, give me at most 1K bytes of data. That's what that 1K is saying. Then we're getting that 1K bytes, and then we're receiving this. Oh, I got to remove this dot strip. Because I see that in students' code far too often. This is just an example. And I'm showing you how the TCP stuff works. And then so many students just cut and paste this without even thinking about it. And I don't know. Think about the code you're writing, please. I see that in office hours far too often, and sometimes messes things up. So anyway, we're going to receive at most 1K bytes off of the socket. So if we have a 1.8 megabyte file, we're not getting the entire request. We're not getting all of the bytes that are uploaded to the server that are sent over this TCP socket. So we're going to have to read multiple times. All right, I have a warning later in the slides, but I'll mention it right here. You could increase this number, but that is something we're going to look at during grading. If you just jack that number up to like a gigabyte, you're not getting full credit. Like you're getting probably a 1 on objective 4 if you just do that, because come on, you're not learning what you're supposed to be learning at that point. So we're going to have to read from multiple times. So depending on how you're using it, the setup's going to be different. I'll show you an example in both JavaScript and Python, because both of them work pretty different. And no matter what language you choose, it's going to, anyone that I've looked into, I should say, I'm sure there's one that's really strange, but anyone that you're going to use is going to fall into one of those two camps, one of those two ways of doing things. So like I know Scala and JavaScript and Java all do things pretty much the same way. It'll be the same idea as our JavaScript example. So we're going to send information to the user's going to send information to the server. Over this TCP connection, we read that, and then we return some request. But what if we have this very large upload? So this is our TCP connection, and the user's sending a whole bunch of data over to us, a very large file upload. And we go to the TCP socket and we say, give me some bytes of data, and we get the first chunk of that request. How are we going to handle this when there's a whole bunch of data and we have to read multiple times? How many times are we going to read? How are we even going to write the code to read multiple times? For JavaScript, you kind of don't even write code that reads from the socket. So how are we going to handle this? And there's many ways that this can happen. The one we talked about, the browser sending just the headers and then the body of the request. But what if any one of these other scenarios happens? User has a slow connection. What if the internet decided to reroute packets? Maybe a line got severed like during the connection, or just a router updated its port no, that's not the right. Anyway, the routing table where it sends knows when to send a packet to the next router. There's a cool name for it. I forget what it is, but whatever. It's not important to this lecture, but kind of mad that I don't know what that is. Forwarding table, maybe. Anyway, all right. So we have this very large amount of data, and I got ahead of my slides a little bit. I'm just so excited to talk about buffers. I mentioned all this stuff already. So we're going to read at most a few kilobytes, maybe tens of kilobytes from the socket. Each time we're reading from the TCP socket. So how are we going to get all this information? This is what we have to do. And then, by the way, in the slides, I'm just going to propose the question for the most part. The actual answer is going to be up to each language, so I'm going to go into the demos to talk about solutions and how we're actually going to do this. Just a heads up on that. If you're waiting for the answer in the slides, it's not really going to come. So we have these very large file uploads, and we need to read multiple times. So what we're going to do is read bytes from the socket. We're going to read from the socket once. We're going to assume, and this is, not too strong of an assumption, but we're going to assume that we've read all the headers in one read from the socket. So we might have this huge file in the body of the request, but in that first read, we're going to assume, at least in this class, that this is a safe assumption. You don't have to make this assumption, but it's not something I'm going to require that you don't make this assumption. So I'm going to allow you to make this assumption, that you read all of the headers up to the blank line in the first read from the TCP socket. So we're going to assume you got all the headers. And usually headers have a fixed size that servers are going to deny any requests where the headers are too large. So this is fairly safe. If you have a large enough buffer, you're always going to get because the browsers will enforce that too, usually. You're reasonably guaranteed that that's going to work, even in the real world outside of the class. But we're going to read the bytes from the socket and parse all the headers. So we're going to assume that we can parse the headers after one read. In the headers is going to be the content length. We're going to read the content length header to figure out how many bytes we're supposed to read from the body. So in that situation where we get the headers of the request and the browser hasn't sent the body yet, we're going to look at that content length and know, okay, we've read 0 bytes and we need to read this many bytes, content length number of bytes, and we're going to read from that socket until we read that many bytes and then process the request. So parse the headers, check the content length, and keep calling, however you do it in your language, keep reading from that socket until you've read that many bytes after the blank line, after all the headers in the blank line, that many bytes from the body only. Doesn't count any of the headers, the request line, or that /r/n/r/n that denotes the end of the headers. It doesn't account for any of that, only the body for the content length. Content length is only the length of the body. So read that many bytes after that blank line, and once you read that many bytes, once you've called receive enough to receive that many bytes that you're appending, so you have some byte array that you keep appending to, keep storing that data in some data structure. And then once you've read all of that data, content length number of bytes, then you're finally ready to process that request. So this is how we're going to be buffering. We receive information, we know we didn't get it all, we're going to start buffering until we receive all the data. Once we get all the data, then process the request. Don't start processing before you have all the data, because things are going to break. You might not even read enough bytes to get the first boundary in the case where only the headers are sent and none of the body is sent. You're going to read content type, you're going to read the boundary, you're going to look for the boundary. It doesn't exist. You get empty strings returned from your splits if you're using splits for the boundary. You're not going to be able to parse it. You're going to be looking for headers in empty strings. It's not going to work. Read all the data, read content length number of bytes before you process. If part of your last header doesn't make it in the first go, part of your last header. So we're going to assume that we get all the headers in the first read. We're going to assume we get all the headers up until that first new line. So for this class, we're going to assume that that's not. If you don't want to do that, if you're like, no, I'm not cheesing it, I'm doing it the way we have to do it in the real world and being 100% robust. If you want to do that, read from the socket until you find that new line character. Look for that sequence of bytes. If you don't find that, enter buffering for the headers. Buffer the headers until you see that new line character, that blank line. And then once you see the blank line, then you can parse the headers and then decide if you're going to continue to buffer. That would be the full proper way to do it. I'm not going to require it in the class because if I require it and you don't do it, your stuff's still going to work. And then, I don't know, it's just an extra thing that you have to do, that the graders have to do, that doesn't give you more functionality or really understanding of web servers. But that would be the proper way to do it. But for our purposes in this class, you can just assume that you've read all the headers in the first read. The cookie headers don't make it all the way. I mean, it's possible that your request headers are larger than a K. But you shouldn't have cookie headers. Why do you have cookies on localhost? You shouldn't have cookies unless you set them on localhost. Maybe we can talk outside of class about that. Blue Truth. My eyes were bugging out. Yeah, Blue Truth. Maybe we can talk after class, or send me a message, send me a DM on Discord, and we can talk about it. Sounds like a specific situation because the only way to get cookies on localhost, I think, actually, unless you're not using localhost, I'm thinking about this. I have seen this before. If you're using an IDE to open your HTML, it won't open using your server. It couldn't be the case here, right? But the IDEs do often set cookies and a lot of extra headers for you. But if you're serving the HTML from your server, the only way to get cookies would be if your server set them or if you and your browser set them. So it's strange that you're getting cookies on localhost unless they're your cookies. And if they're your cookies, just stop doing that. Stop having very large cookies when you're testing your stuff. All right, so assumptions we can make in homework 2. You can assume that only one user is uploading at a time. Well, first, we just talked about this one. So your first read contains all the headers, so you can read content length right away and decide whether you have to buffer or not. But you can also assume that you only have one simultaneous user uploading a file. So you're not going to have 2 users uploading files at the same time. That's not something we're going to test. It's not something we're going to check. We're saving that for homework 3 when we have WebSockets, when we are going to spend a lot of time talking about concurrent users. With WebSockets, we have to have concurrent users with concurrent connections. We're going to save that whole conversation for homework 3, where we'll start talking about that next week. That's a big topic. I don't want to jam it into homework 2, so we're going to push that off to homework 3. Yeah.
For like the receive, where you talk about like if you were to increase it to 1 gigabyte,
is there scenarios like different content where we want to have smaller like receives or larger, or is it just buffers?
It's I mean, probably if you really get into performance issues, but it would be not something we'd be concerned with at this level. But it's possible. I want to hedge my bets a little. I want to say, nah, we don't really care that much. But it's possible there are some performance optimizations where you get that perfect number in there. But if it's a few K, I would say that's where we want to be. Like if it's really large, are you saying if you set it to gigabytes? If you set it to gigabytes, you might run into some issues.
I was saying like for like a streaming service or like YouTube or something, would they be wanting to take in gigabytes at a time for like video information, or is it still more efficient to use a buffer and do kilobytes for like a video or something?
I guess they always want to use buffers. I don't want to say, I'm hesitant to just give a hard and fast answer because there might be something that like at YouTube they found this really crazy way to do things. But I'd say they only want to read it a little bit at a time. Like they'll send it, they can send it in, well, they probably send it in chunks too, and then have those bytes sitting on the TCP socket waiting to be read, and then read them a few K at a time. But I don't see much advantage Like, it doesn't take long to go to the TCP socket, like, to read more information. Reading the information is going to be the bottleneck there anyway. So whether you're reading it 1K at a time or 20K at a time, it's still the reading, the total amount of bytes you got to read. So I don't foresee any big gain. The one thing that I could foresee is if the socket, if you're reading like a gigabyte at a time, or megabytes at a time even, that you're gonna slow other things down. When you have a lot of concurrent code, that's okay, I have to go grab a gigabyte, I need this thread for a while. That could start causing performance issues. So I would say in general you want a smaller buffer, but again, there's probably applications where you want very large buffers, and so I'm not gonna give a hard and fast answer on that. But that's a good question. It's a good thing to think about. And you're gonna have me wondering, what would I want? Like, what if we put the buffer to 1 byte? How bad would that be? That sounds bad, but why and how bad would be an interesting question to explore. And we're going to test with files that are larger than your buffer. We're going to look through your code, and if you do this, like I said earlier, if you do that, it's going to be a 1. If you just say, well, I'm going to receive as many bytes as I need to read anything that they're going to upload during testing, we're going to look at that. First of all, if you hard code it like that, that's going to be an auto 1 for the for objective 4. But also, if you do this, we'll overload that buffer too. We'll send some file that's larger than this, just to make sure that you are actually buffering. So no cheesing it like that. We're obviously aware that that's something that students like to do. It's not going to fly. You're not going to get your score. It's not going to work. It's not going to work for your grade. All right, let's get into some demos, which hopefully work fine this time. So we're going to start with Node. So again, I have this very basic Node server, and I should just start showing you bigger servers now that homework 1's done. I don't know. But this is all we need for this case anyway. I'm always afraid to show bigger servers with more functionality because I'll just be leaking homework solutions. And I always see students that watch the video and just copy down character for character what I did. Even for homework 1, I see this a lot. Character for character what I did. And then they go to office hours with that and say, what do I do now? Like, I don't know. Pay attention to, I don't know. For those reasons, I don't like showing too much here. But I have some code here. We have this function, this method, this function method that has a function as a callback, I guess, that's going to receive data off of the TCP socket. So this is how we're receiving data in Node. This works through callbacks. So we're going to start the server. We're going to start the server, and then this net library is going to call this function, our callback function, every time there's data to be read off of the socket. So on the data event, there's data on this TCP socket to be read, call this function. So that's what, and then everything else is behind the scenes, all the TCP stuff. So a few things here, we never got to like specify the TCP connection that's being made, and we never specified a buffer size. So a few kind of question marks with this. It seems like mostly magic. You just have this data, you have these bytes and data, and then you write your code. So let's demystify a few things here and explain through what's going on. So we have this socket object. This socket is going to be one single connection. So we have the socket server, which every time it has a socket connection, it's going to get a socket object. And that's going to be one connection with one client. You can have multiple clients, of course. We like our websites being nice and concurrent. We like a lot of concurrent users. The socket object is going to be one specific client. And we can identify that client using some whatever identifying information we want. I like just using the remote address would be enough, but remote address import would be robust, would be comprehensive. You can't have two clients with the same remote address and port, the same host and port. So this would be an IP address, and this would be a port number. Can't have two TCP connections from the same host on the same port. Just can't happen. TCP won't allow it. So this uniquely identifies a client. So we can get that from the socket and figure out, okay, we just got data. Which socket did we get data from? We're going to read these two pieces of information to get that. For homework 2, that's not as critical because we have the simplifying assumption of one concurrent connection. For homework 3, this will be crucial. You got to read this information to know which connection this information came from. And now from that socket, we know we have some data coming from this client. So again, I'm just printing things to the screen so I don't leak stuff. But I'm going to say I received data from a specific client, and I received this many bytes. I'm going to get the length of that data and see how many bytes of information I'm getting in one go. I'm going to print out that data for now. I'm going to do some parsing and just print out some things. And I'm not going to send anything back, so this is just going to hang. It's not going to have any functionality. It's just going to hang. But all I want to do is see what's being printed to the screen. So let's go to Finder. Oh, I already had it open, didn't I? And this is actually something you can do. Oh, I clicked the wrong one. So I have some HTML. This is actually something you can do. I'm going to hard code this path to be from a different host. So I'm going to actually open this file just using the file protocol. And this may or may not be helpful for your cases, but I have a JavaScript server and a Python server, and I want to use a single HTML file. This is the easiest way to do that. I'm going to hard code the action not just to a relative path, but an absolute path, which is going to go to localhost port 8000, which is where my server is going to be running. And then it's just a file upload form, like we've seen before. Simpler than we've seen before even. It's just the file upload and a button. So I'm going to open this, figure out where it is. My Finder window, oh, because it's, let's see. Finder window was on the wrong desktop. So I just have this very basic, simple page. I'm going to choose a file to upload. Let's upload something. Let's upload this Python file that's 2 kilobytes. Open that, upload it. I didn't even run the server. Why did that even give me a 404? The server's not even running. I forgot to run it. Oh, because that is strange what's running, but all this got messed up because my laptop restarted. No server, is that going to say port already in use? Sure it is. Oh, this server's running. Too many servers. Oops. Now we'll refresh. Oops. Now we'll submit. That's going to hang intentionally, and we're going to see what we get in the request. So right here, you can see we got from this user, localhost port 51,789, which is a random port that the browser chose for this connection. I got 676 bytes. Here they are in all their glory. And then from my parsing, I can see what I got from the request line, those 3 parts. I would like this to print out more meaningfully. All right, so I got far more bytes this time, for what it's worth. So the browser on 2 separate uploads of the same file, I got different behavior. It happens. That's why we're buffering. I got a content length of 2660. I got all my headers. Got my boundary. Got my boundary after the blank line. We're going to start the request, the body of the request. And I can see the actual content of my Python. The browser even identified that as a Python script. Probably either looked at the file extension or it had to be the file extension, right? It's just text. Or possibly read the code. And then the code of the file that I uploaded. Hopefully nothing leaking there. Oh, it's my 312. It's a 312 website main Python file. And the parsing that I'm doing at the end. Let's try that again. I want to see if we can get it as 2 requests again. Oops. Which time we got? Do I have time to? I got time to mess around with that. Anyway, let's upload a larger file. So that we've seen before. That actually was 2 requests. Actually, now that I'm seeing it. Yeah, here's the start of the next request. So we received, this is what I want to show. So this time, it happened the same way it did the first time. Received 829 bytes. Now, our buffer is a lot larger than that. We didn't specify a buffer length. We'll explore that in a second. There is a default buffer length for a node net server. But we got 829 bytes. The buffer is much larger than that. But we did get all of the headers. So the end of it's right here at the blank line. And we are able to parse content length, most importantly, and all of our request line headers. And then we received another 2660, which started at the first byte of the body. And then we got the body in a second request. And then we can parse the body. So even there, small file, the entire request obviously fits in our buffer because the last time we uploaded that, it worked. So sometimes we get that behavior and sometimes we don't. Sometimes we get the whole thing. All right, let's try another file. Let's get things more interesting here. Let's go to this file here, which is CSE 442 lecture slides. This is a 10 megabyte file. This is a little bit bigger. So let's upload this and watch a whole bunch of bytes go by in our console. So I'm just pairing to the screen, so I'm getting all these decoding errors because this is not UTF-8, it's a PDF, or not a PDF, a PowerPoint, I think. Was it? It doesn't matter. So we can see all these bytes. We're receiving 10 megabytes of data in this request. We can see all the information fly by. And we should see the boundary at the end. Oh, I think my code breaks here, though. Intentionally, by the way. I can't parse, because this is something I want to talk about. So now we're going to go find those stars, and I want to see the boundary of each request. And it's not going to do it for me. I know why, but I was hoping I'd at least get one. So, but this intentionally breaks because I can't parse that request line. So I'm trying to parse the request line every time I'm reading information from the socket. But after the first time I read for a single request, I'm reading just a whole bunch of bytes that are part of the file. And I'm trying to find the first line, which line doesn't make sense when it's just a bunch of bytes, and then parse that line, splitting on spaces. I'm going to get an index out of bounds error somewhere in here because I just can't parse that data as a request line. So as that's flying through again, so that's intentionally, that of course breaks here. So let's do that again. Oh, and two stringing. Everything's going to break there. But let me get rid of this line. Let me restart. Oh, I didn't even restart the server. But let me get rid of that line. So instead of printing out all of that garbage, and notice it uploads a lot faster when I'm not printing to the screen. Printing to the screen is a very slow operation. So now that I'm not printing to the screen, I'm just going to print the number of bytes that we're getting each time, and we can see the default buffer size of 64K. So now we're reading this in 64K chunks each time we're reading from the TCP socket, and we have to read a lot of times. So the very first read that we have, we're going to assume has all of the headers. We're going to parse the headers and see how much we need to read, and then we're going to track that. We're going to say in some variable up here, or up here rather, either way, but something outside of the scope of that callback. We're going to say, hey, I'm in the middle of buffering, and I have this many bytes left to read. And then each time you read, you're going to say, okay, let me track this, let me append this to my buffer, get all these bytes appended, and then decrement however many bytes I just read from my bytes that I need to read, and just keep doing that until the bytes you need to read is 0, and then you start parsing. So once you get here, you have some conditional. If I'm buffering, read and check if I've read all the bytes I need. If not, don't do anything. And then we get another request, or not another request, we read from the socket again. We're going to read 64 more bytes. Okay, am I done buffering now? No? Okay, don't do anything. And then you just keep doing that until you finally hit the point where you've read content length number of bytes, and then you can say, okay, I'm good now. Now I can start parsing this request and saving that file, saving that image to a file. Yeah. Yes.
Just to clarify, content length is only for the content, right? So when we receive the bytes, do we have to remember to check how many bytes the headers are and remove that from, or not remove that?
Yeah, so you're going to check for the new line, the blank line, that says this is the end of the headers, and don't start counting bytes until after that. So you're going to look for that new line, take that, remove that, take everything before it as the headers, and then everything after that, you're going to start counting bytes. So let's switch over to Python. So that was the Node example. Any questions on the Node example, by the way, for those of you using Node? All right, let's talk about Python. Python's a little different. For Python, every time this handle method is called, it's going to be called on a per client basis. So now instead of getting this called every time any client, like in JavaScript, our callback was called anytime any client sent us data that we were receiving, this callback was called. One callback function for every single client, and the requests can be intertwined in that callback. So we want to check, is this the right client, especially when we get to homework 3. Which client is this is going to change the way you handle that request. Is this client currently buffering? Is this client a WebSocket connection? Is this client sending a GET request? What is this client doing? For Python, handle is called once per client, so per connection. So this function is only called when you get a new connection and only once per client. And then it's up to you to read the information off of that TCP socket for that client. So we have to read this information here. And let me just send some information. Let's get this thing running. I want to send it. Oh, let me start with the small file. Send it a Docker file. So we get the connection, we receive the bytes, and then let me make this hang. This is from a previous example. I want to print received data. But we got all of that information in one go. We got all that that data. Right? Did we? Maybe I should double check since we know it's different each time for this browser. Yeah, no, we only got the headers. So we only got the headers there. So how are we going to get more information? Well, I am going to actually, let me do it right here. I'm going to do this. I hope it's obvious that you should not do that at the top level. But I'm just going to keep running this multiple times. So we want to call receive multiple times when we're in this situation. You don't want to just wrap everything in a while true loop. You might have a while true at some point. Don't just put it at the top level like this, of course. But this is going to allow a single connection, a single client with a single TCP connection to send us more than 1K of data. So let's rerun this. Let's send that file again. It should hang. And hopefully we get to see 2 requests. Yep. So sending data and sending data again. And I guess for good measure, we should print out the length of this. I don't want to print the whole thing. We've seen requests before at this point. Oh, Python. Give me my port back. All right, well, once it's running, I'm going to not rerun it again because I don't want to wait for my port. And I want to update the, so I would just change the port, but then I got to change it in the HTML as well. I'm hoping it's just quicker to, fuck. Let's just change the port. We got to refresh this. Let's just go right to the big one. And some extra print statements. And we can see that we're getting our data 1K at a time from the same client each time. I'm appending that client to an array each time and printing that out. That's what the extra garbage is. I'm not going to restart the server to get rid of that. But we can see we're getting the request 1K at a time. And you can tell how many times I had to send to get 1K at a time to send this 10 megabyte file. It should be even more than that, I feel like, but a lot of times. So we go, so in Python, we have a connection. We're going to go to the TCP socket. We're going to receive some bytes, parse that as headers. And if we have a content length and we haven't read that much data yet, we're not going to go into a well true, but we're going to go into a well I haven't read content length number of bytes. Well, I haven't read content length number of bytes. Keep reading and appending to your buffer. Now, this gets a little easier because you don't, especially when we get to concurrency, because you don't have to worry about multiple buffers and everything for each client, because each client will have its own handle method being called. And one more thing I want to show. So I'm using a TCP server here. This is hanging. If I go to another tab, choose any file and upload it, and go back to my server, I'm not going to see that next file. I'm not going to see any information there because my one client is plugging everything up. It has full control over the thread that I'm trying to use. So I'm not able to, oh, come on, did I lose my... So I have no control over my program anymore because that one thread's going to hang forever. I got a well true. It's trying to read. It's going to hang right on this line, the receive line, because it's waiting here until there are bytes to read, and there are no bytes going to be sent by the browser. The browser's not sending anything more. So we're not going to get any more information. Just hang here forever. To fix that, we add one word, threading. Quickly change my ports. That threading is a very important word. refresh, choose file, upload, back, choose, oops, I didn't refresh, choose file, upload, and we can see that we'll have both clients able to send information. We can have concurrent connections. Trust me, there's two different port numbers in there. We can have concurrent connections with that word threading. Now each client is going to run on a separate thread, and we're able to have concurrent connections. All right, I'll see everyone Wednesday.